Here we have a SAT math problem. Okay, let's go to the question. F of x equals to ax squared into 7x positive c. The function f is defined above where a and c are constants. The graph of y equals to f of x is a parabola that has a vertex at the point h comma k where h and k are constants. If f of negative 9 equals to f of 92 and c is greater than 0, which of the following must be true? Here we have two statements. One is a less than 83/4 and other one is k is greater than 16. We have to check whether the first statement is true or the second statement is true or both of them true or both of them are not true. Okay, now let me consider the information we have over here. That is f of negative 9 equals to f of 92, and also we have an information that y equals to f of x. That is, this f of negative 9 is a value of y. This f of 92 is also the value of y. Actually, this is the value of y when x equals to negative 9, and this is the value of y when x equals to negative 2. Here, for this quadratic function, for two different values of x, we have the same value of y. In a quadratic function, for two different values of x, when we have the same value of y, then the average of these two x values must be the x coordinate of the vertex, that is h. Okay, now let me get the average of these two x values, that is negative 9, negative 2. I have to add them and divide by the number of values, that is 2. Then I'm getting h equals to negative 11 over 2. Okay, here I got the x coordinate of the vertex. Okay, now let's consider the given quadratic function. It is in standard form, that is f of x equals to ax square positive bx positive c. When we have a quadratic function in standard form, there is a formula to get the x coordinate of the vertex h, that is negative b over 2a. We have to take negative sign and consider the coefficient of x, that is b. It should be taken in numerator. It has to be divided by 2 times the coefficient of x square. Okay, now let's do the same thing for this quadratic function to get the x coordinate of the vertex, that is h equals to, we have to take a negative sign. Now we have to take the coefficient of x, that is negative 7 divided by 2 times the coefficient of x square, that is a. Then we get h equals to negative times negative is a positive, that is we get 7 over 2a. Okay, here I got the x coordinate of the vertex. Already we have the x coordinate of the vertex. So we can equate them. That is 7 over 2a equals to negative 11 over 2. Now let's take a reciprocal on both sides. Then I'm getting 2a over 7 equals to negative 2 over 11. Now to solve for a in this equation, I have to get rid of the fraction 2 over 7, which is multiplied by a. Now let me multiply both sides of this equation by the reciprocal of the fraction, that is 7 over 2. Let me do it. Then this 7 will cancel out, 2 cancel out. I'm getting a on the left side. Here this 2 will cancel out. I'm getting negative 7 over 11. Okay, now let me get the exact value of negative 7 over 11. When I divide 7 by 11, I'm getting a very long decimal. Let me, that is 0.6368, it keeps going. Let me round this value to the nearest 100. Then I'm getting negative 0.64. Okay, here I got the value of a, that is a negative 0.64. Okay, now let me consider the first statement over here, that is a is less than negative 3/4. What is the value of this negative 3/4? That is exactly negative 0.75. That is a is less than negative 0.75. Now let me take the number line and let me take 0 over here and let me take negative 1 over here, and we'll have this value negative 0.75 about here. Let me mark it. And we have this value negative 0.64 to the right of negative 0.75. Let me take it over here, negative 0.64. Always the value we have on the right side is greater than the value on the left side on the number line. So clearly negative 0.64 is greater than a negative 0.75. But here the first statement says the value of a is less than negative 0.75, but the value we got over here for a is greater than this value negative 0.75, because we have this value to the right side of negative 0.75 in the number line. So the first statement a less than negative 3/4 is incorrect. Okay, now we have to verify the second statement. Now let me erase this stuff and continue the problem. Okay, already we got the value of x coordinate of the vertex, and that is the value of h, that is equal to negative 11 over 2, and also the value of a, that is equal to negative 7 over 11. Now let me write the quadratic function in vertex form, that is f of x equals to a times x negative h whole square positive k. F of x equals to, now let's plug in the values of a and h over here. It is negative 7 over 11 times x negative, and the value of h is negative 11 over 2, the whole square, positive k. Okay, f of x equals to negative 7 over 11 x, and negative times negative is positive 11 over 2, the whole square, positive k. Now we have to expand the square of the binomial over here. For that, we can consider the algebraic identity, that is a positive to the whole square. The expansion of the square of the binomial over here is a square positive 2ab positive b square. Okay, now when I compare this one and this one, at the place of a we have x, at the place of b we have 11 over 2. Now to get the expansion for this one, we can consider the trinomial over here. In this trinomial, for a we have to plug in x, and for b we have to plug in 11 over 2. Okay, now let me do it. Then I'm getting f of x equals to negative 7 over 11 times x square positive 2ab, that is 2 times x times 11 over 2, positive b square, that is 11 over 2, the whole square, positive k. Okay, now let me continue over here. F of x equals to negative 7 over 11 times x square, and here this 2 will cancel out. I'm getting positive 11x, and when I evaluate the value of this one, I'm getting 121 over 4 positive k. Okay, then f of x equals to, we can distribute this negative 7 over 11 to all the terms we have inside the parenthesis. Then I'm getting negative 7 over 11 x square, and when I multiply this negative 7 over 11 and positive 11x, I am getting negative 7x, because when I multiply this one and this one, this 11 and 11 will cancel out. Okay, now let's multiply this one and this one, that is negative times of positive is negative. Okay, now let me do this multiplication separately, that is 7 over 11 times 121 over 4. 11 goes into 11 one times, and 11 goes into 121 11 times, and 7 times 11 is 77, that is we get 77 over 4 positive k. Okay, here I wrote the quadratic function in vertex form. Finally, I simplified the quadratic function to the standard form, in which we have the given quadratic function. Okay, now let's compare the quadratic function we got over here with the given quadratic function. Let me write the given quadratic function over here, that is f of x equals to ax square negative 7x positive c. We have a x square term, x square term, x term, x term, and this is a constant term. Here the constant term is c. At the place of c, we have negative 77 over 4 positive k. So that is the value of c equals to negative 77 over 4 positive k. Now, let me consider the information we have over here, that is the value of c is greater than 0. Now, let me plug in this stuff for c over here, then I'm getting negative 77 over 4 positive k greater than 0. Now, let me solve for k in this equation. For that, we have to add 77 over 4 to both sides of the equation. When I do so, this negative value, positive value will cancel out. I am getting k greater than, when I combine this 0 and positive 77 over 4, I am getting positive 77 over 4. Okay, here when I simplify this value, I am getting 19.25. That is, any value greater than 19.25 can be considered for k. Okay, now let me consider some values for k which meet this inequality. Then we can consider 19.3 or 19.5 or some integers like 20, 21. So all the values I have taken over here are greater than 19.25. So these values satisfy this inequality. Now let's go to the statement 2 over here. Statement 2 says k has to be greater than 16. Okay, now we have to check the values we have taken over here for k which meet this inequality will satisfy the inequality we have in the second statement. 19.3 will satisfy this inequality because 19.3 is greater than 16. So all the values we have for k with this inequality will be greater than 16. So the second statement is true. In the given two statements, only the second statement is true. In the given answer choices, we have to find the one where we get the second statement. That is in answer choice B. Therefore, the correct answer choice for this question is B.